All right, so we've been talking about the algebraic system, right?
Yes.
Okay. Remember that the only difference between algebra and arithmetic is the introduction of those variables, the letters, right? And they're called variables because their value can vary depending on how they're used. Excellent. Good job, guys. All right. And remember that when we introduce those, it changes the building blocks. Changes the building blocks of our mathematical system. We no longer have just numeric terms or number terms. We now have algebraic terms. And they're algebraic because they have a what in them? A variable, a letter. Yeah, that's what makes it algebra. So that's what makes it algebraic. Okay? And they're terms instead of just numbers. And every algebraic term has exactly how many parts? 4 parts. What's the first part of every term? Sign. So you can always tell where one stops and the next one begins every time you see one of those pluses and minuses. Right? Critical that you know that. Second part of every term is its coefficient. Now, coefficient is a fancy word for multiplier. And the coefficient of a term is always a number. But does that mean every coefficient is always a number? No. Coefficient means multiplier. It's just because we're talking about a term that it's a number, right? What color are your shoes when you're wearing your uniform? Always. Black. Does that mean every shoe is always black?
No.
Does that mean that the only things that are shoes are black? No. So you see what I'm saying? So it's a specific use, you get a specific thing, right? So don't be too global. Yes, ma'am. Of course. All right, now. All right, so then what's the third part of every term? The base, which is always the variable, the letter. The letter is the thing that you base everything on in an algebraic term because that's what makes it an algebraic term. Make sense? And on every base, whether you see one or not, there is an exponent. You betcha. An exponent. So when you have the exponent on every base, whether you see one or not. Okay? All right. Now, what if you don't see a sign? You assume it to be a sign. Positive. There you go.
We said it.
There you go. Oh, well, I didn't hear you. I'm sorry. All right. Positive. Okay? We said it. They're merging together to slowly becoming one person. All right. You too.
Oh.
All right. Okay. Then, if there's no coefficient, what do you assume it to be? 1. Can I write in a 1 if I don't see a 1? Yes, it's never wrong. It's just not algebraically beautiful, but big deal. Who cares? It's not wrong. I don't know. Some people do. All right. Mathematics it's actually the real mathematical term for that is mathematically elegant. It should be as elegant as possible. There you go. All right. We're not going for elegance. Okay. What about an exponent? If you don't see an exponent, what do you assume it to be? A 1. In mathematics, most of the time, now there are some exceptions. Are there exceptions to every single rule? Yes. There are some exceptions, but most of the time in mathematics, if you don't see a number, you can assume it is a what? 1. Because there's no reason to say, look, I have 1 pen. I have a pen, right? Right? You don't usually say if you have 1 of them. But if you have 2 of them, do you have to say 2? Yeah. Absolutely, because you have a number of them. Mm-hmm. Okay. So we talked last time about combining like terms. Yes? Combining, or we used to call combining in arithmetic, we call combining add or what? Subtract. But in algebra, we call it combining because you're not really using, because a plus can sometimes mean positive. Yeah, well, but a plus you'll sometimes end up subtracting, and a minus you sometimes end up adding, because those pluses and minuses are the signs of the terms. Remember that? Because like if you have a negative and another negative, the answer stays negative, and what do you do to the numbers? Add them. If you have a negative and a positive, then you keep the sign of the larger one, and what do you do to the numbers? Subtract them. So sometimes what looks like addition actually turns out to be subtraction. What looks like subtraction actually turns out to be addition. So you can't think of it really as add and subtract anymore. Think of the sign rules, those rules for integers. Okay? And let me tell you that if you want to make sure that you do not succeed any further in mathematics, you can go ahead and ignore the sign rules. If you don't know them backwards and forwards and just eat, sleep, live, and breathe, those sign rules, then you will not go forward in mathematics. All right? It's that critical. It's just like you need to know the alphabet in order to be able to spell, right? It's that important. If you don't know the letters, you can't, right? Can you? Okay? Same thing. If you don't know the sign rules, you're not going to be able to go forward. So we need to work on that. For those of you who are wishy-washy or just have some issues with that, we need to work on it. Okay? And the only way you can do it is just to simply memorize it. Sorry, guys. All right? Now, today we're going to talk about not combining like terms, but we're going to talk about multiplying algebraic terms. All right? But remember when we were combining, first we looked at the sign to see if we were going to be adding or subtracting the numbers. Then we added or subtracted the numbers, and we kept the base, right? Well, so in other words, we took each piece of the term independently. Well, that's always what you do with terms. And so you're going to see that same thing with multiplying. Now, the multiplication homework that you're going to have, the first homework that we have today, is very low level. It's just basic ideas of terms. So very few signs, very few and no exponents. But I'm going to give you the notes for the whole thing. So because I want you to see everywhere where you're going with these. So to multiply terms. So you're not going to see all of this in your homework today. We're going to do homework on this now, low level, then we're going to kick it up a notch. Okay? So, all right. What's the first part of every term? The sign. So the first part of when you're multiplying is you determine the sign. And do you remember the sign rules to multiply? To multiply or divide, remember the sign rules are the same. If the signs are the same, the answer is always a what? Positive. So positive times a positive stays a positive. Negative times a negative becomes a positive. Right? So if the signs are the same, the answer is always a positive. If the signs are different, the answer is always a what? Negative. Different gives you a negative. That's very different to get a negative, right? All right. So positive times a negative is a negative. Negative times a positive is a negative. Right? Because the signs are different. So if the signs are the same, the answer is always a positive. If the signs are different, the answer is always a negative. Okay? We learned that in our integer rules, but it's been a while since we did number, isn't it? Okay? Second, what's the second part of every term? Coefficient, which is the numbers. And that's what you'll work with next. And you'll simply multiply the numbers. Well, I don't want to write numbers. I want to write coefficients. I want to use the right language, right? Multiply the coefficients. So a 4 times a 3 is still 12, just like it always has been, right? And you've already got the sign there because you determined that first. Get in the habit of doing that. Most students want to multiply the numbers first and then go back and put in the right sign. Don't do it. Trust me. 22 years of doing this, I can tell you the thing that destroys more students all the way up to university level is sign rules. So, do the sign when? First. If it's the most problematic thing, you should always focus on it first. Does that make sense? All right. What's the third part of every term? The base. And just like we did in combining, we're just going to keep the base. An A is going to be an A. It's not going to change to a B, right? All right? What's the fourth part of every term? The exponent, right? Every base has an exponent whether you see one or not. Now, this part is not going to be in your homework for today, but it will be next time we see each other, okay? So, what you're going to do is add the exponents on like bases. And we'll talk about this. This is the part that, if anything gives you any trouble, this is going to be the newest thing, right? Shouldn't be new to you because you probably had an introduction to algebra in year 7, but we'll see. Okay? Now, so what we're going to do is I want to talk a little bit and expand a little bit about exponents. And the first thing I want to tell you we want to do is we want to see why we're adding them. Because an exponent, all right, we're multiplying terms, first of all, and an exponent means multiply over and over. So everything here about an exponent and multiplying terms should scream multiply. But because they're exponents, the shortcut is to add them. You don't multiply them. And here's why. What if I had a squared times a to the third? Let's expand that. Tell me what that means. A to the second literally means a times another what? A. Right? Then I'm just going to bring down that multiplication symbol there. A to the third literally means what? A times A times A. You bet. So 3 of them multiply together. Okay? Now, if I was going to rewrite that as exponential notation, is it the same base multiplied over and over again? Yes. No. And how many of them do I have? 5. So I would write it as a to the what? Well, isn't a to the 5th the same thing as a to the 2 plus 3? Yeah. So it's a shortcut. Instead of having to expand them all out and then count up how many a's I have, I can simply do what to the exponents? Be careful. Add them together. All right? Okay. Now, but be careful. Notice it says on like bases. So if I have a to the third times b to the second, that's a times a times a times b times b. So can I write that as something to the 5th power? No. Nope. It stays a to the third, b to the second. I can't do anything to it. So it has to be the same bases. So that's the only way. You can only add exponents on like bases. So if it was b to the 4th times b to the 216, what am I going to get? B to the what? B to the 220th, right? Right? Doesn't matter how big the numbers are, just add them together. Would you like to write out how much 216 b's and then count them up? No. So that's why we use the shortcut, guys. Okay? All right. So on like bases, you just keep the base and add the exponents. Yes? What if they're different bases? Sorry? What if they're different bases? Then you can't do anything. That's like this one. You just stick them side by side. Yeah? Because remember, all right, so we know how to multiply terms, but we need to talk a little bit about how we know that we're working with multiplication. All right? So I'm going to turn the page. Ready? So what we want to talk about is the operation symbols for multiplying terms. Because remember, algebra is all about the elegance. So we don't want to write anything we don't have to. We want to write it and make it look pretty. So we're going to see that in algebra, if you don't have to write something, they won't. Like an A. How many A's? But do you have to write the 1? No. Right? And the same thing happens when you have operations. What do you think is the most common operation in all of mathematics? Plus. Actually, it's multiply. Okay? So since it's so common, we look for ways that we can simplify it and make it as easiest to write as possible. Okay? Now, so if we wanted to write multiply 4 times a, many times we use the x to represent multiplication. I got a problem with that. Is it? Because how do I know if that's the x for multiply or if that's x the variable? Now, most of the time, what you guys do is you simply use the standard x for multiplication, and then if you want an x, then y'all write it with those like 2 C's stuck together. That's perfectly fine if you do that. Okay? So use this one as the multiplication. Oops, mutt. Not mutt, but then. Or you use this one as the letter. That's the standard format in New Zealand. Now, we don't do that in the States because we're too lazy. All right? So what I would write is something that I've used in the past, so you guys are used to it. I simply replace the x with a dot. The dot means to multiply. And the reason that in like the Commonwealth, the British areas, we don't do that. In some countries in Europe and some other countries, when you're writing a decimal, so like 4.5, they put the dot for that in the middle, up high. Yeah. And that's just weird. Because when you write a decimal, can you float the decimal up there like that? No, the decimal point is at the bottom. So you can tell. Can you tell the difference between these two things? This one is a decimal because the dot is where? At the bottom. This one is multiply y because the dot's in the middle. All right? Do you think you can handle it? Because you're going to see, I can't seem to stop doing it. Oh, well, we all have our stuff, right? Okay. Now, but remember, algebra is about making things as simple as possible. So I don't even have to write any symbol at all. If I want to say 4 times a, I can just put 4a. Because remember, the 4 is the coefficient or multiplier of the a. So 4a literally means 4 times a. You bet. And that is such an important thing to understand, right? So what does it mean if you have a number right next to a letter? Multiply. Right? So multiplication is the only operation that requires no symbol at all. If you want to write division or add or subtract, you have to have a symbol. But for multiply, if you see two things just stuck together, that means multiply. And that can happen with letters too. So instead of saying A times B, I can just write that as AB. Make sense? Right? Can't do it with numbers. 3 times 5 can't be written as 35. Right? So be careful with it. Don't do it with numbers. But you can do it with letters. And you can do it with numbers and letters. Okay? All right. Pardon? You would just numbers, exactly. Okay? Now,
wouldn't it not work if you had like a 2, if you had more than one, if you had like 2 numbers and then an A?
Yeah, that wouldn't work because you have multiplying 2 numbers. If you're multiplying 2 numbers together, you need a symbol. But if you're multiplying numbers times letters or letters times letters, you don't need a symbol. Excellent. Okay? Now, another symbol that means multiply is something that you all use quite frequently. Yes?
But is it alright if you still use times A?
It's okay when you're doing the work, but you don't want to leave it that way. Right? Yeah, you can still write the multiplication symbol. That's no problem for now. But as we move forward, it's going to get really cluttery. And you don't want to have a bunch of stuff on there that you have to try to figure out. Right? If we can simplify it as much as we can, that's great. Okay? Good question. Thank you. All right, so here we go. We can also use a bracket to represent multiplication. All right? Now, hopefully you've seen something similar to this before, but if you haven't, it's no big deal. As long as there's no symbol between the number and the bracket, or the letter in the bracket, then it always indicates what operation? Times. Multiply. We can also have something right behind a bracket. But do you see a plus or a minus or anything between the bracket and the A? Well, no symbol means what operation? Multiply. You can also have both things in a bracket. A bracket right next to another bracket. Do you see a symbol between them? That automatically means that you have what operation? Multiply. Right? And you're going to see all of those cases as we move forward in this class. Okay? So, it's very important that you understand what operation is being indicated, because that's the key to knowing what steps to use, right? Because are the steps for combining the same as the steps for multiplying? Nope. So you have to pay attention to what operation that you have. Okay? All right. So let's take a look at some examples. And what I'm going to do is I'm going to put an example, and then I'm going to put the notes there for you to determine what steps. And remember, when you're working these, that's the part you study, right? Don't just do all the homework and say, well, I'm done. That's not what you're doing. If you can't quote back to me the steps we learned, then you don't know what we're doing. All right? So keep that in mind as we go, because the algebra is a building block. You're going to be in algebra from now on. If you don't understand year 8 algebra, then year 9 algebra is going to be harder. And if you don't understand that, then what's going to happen in year 10? It's going to be worse. And year 11 is going to be even worse, right? It's kind of like not knowing how to spell, right? And then being graded on spelling. You don't want that to happen to you. Okay? So make sure you recognize that that's what's happening. That what we learn now are the basic skills. These are the things that you have to take with you out of this class. Right? So, do I care if you put the water above the pool later? Probably not going to be the end of the world. But do I care if you can't multiply a term? Absolutely. Right? Okay, so here we go. So we're going to do some steps. Oops, sorry about that. All right, so here we go. So say we have negative 4x to the third times 5x to the second. Now this is way more complicated than the ones you're going to be doing in your homework. I'm going to tell you that right now. All right? But I want you to see every piece because I want you to see really how easy it is, as long as you're asking yourself the right question. And the first question you should ask always is what operation? If you don't know what operation you have, then you can't do the problem, right? So that should always be your first question no matter what. Okay? So, I used a dot. It could be an X, could be a bracket, but what operation is indicated here? Multiplication. Okay? And then you need to ask, what kind of things are you multiplying? I know that's a really ugly question, what kind of things, but let me show you why I want to write it that way. Are the rules for multiplying 2 times 4 the same as the rule for multiplying 2 fractions together? Nope. Are the rules for multiplying algebraic terms the same as multiplying just plain numbers? Nope. So do you see why it's not only must you know, you have to know what operation you're dealing with, you have to know what kind of things you're doing it to. Right? And that's why we've spent so much time talking about what is a term and how to recognize a term, right? These are algebraic terms. These are algebraic terms. I know that because they have what in them? The variable, the x, yeah, the letters. I don't care what you call it. I'd prefer you call it a variable. But if you call it a letter, I'm not going to yell at you. All right? If you call it an x, I'm not going to yell at you. Right? Just want to know that you know that that's what makes it an algebraic term. So we're multiplying these 2 algebraic terms. So let's do the steps for it. So the steps. First, I want to determine the what? Sign. What's the sign of the first term? Negative. What's the sign of the second term? You don't see a sign, so what do you assume it to be? Positive, right? Well, a negative and times a positive, are the signs the same or different? And when you're multiplying, if the signs are different, the answer is always a negative. So, negative times a positive means your answer is going to be a negative. Okay? What's the second part of every term? The coefficient. Yeah, so we're just going to multiply the coefficients. So what is the coefficient of the first one? 4. What's the coefficient of the second one? 5. And what is 4 times 5? Usually 20, right? Okay. Don't get creative on me. Then, what's the next part of every term? Base. And what are we going to do with that base?
Keep it.
Just keep it. So it's still going to be an x. And what's the fourth part of every term?
Add the exponents.
Exponents. And when we're working with multiplication, we add those exponents. So 3 plus 2. And here, guys, you will make your life easier if you take that off to the side and write it because of where we're going. So 3 plus 2 is going to give you x to the what? 5th. Do you see how I took that off to the side to write it? Trust me, it will make you much happier in your future if you get in the habit of doing that.
Wait, should we be writing stuff down in our books like this with the examples on one side and...
Yes, so I have the rows on the one side and the example on the other. So right next to this is where the example would be. Okay? So you'd write it just like I've done it here. Okay? So what did my completed answer? Negative 20x to the 5th. And how hard was that? Not at all, because I was reading the rules to you, telling you what to do each time, right? So what does that tell you? If it was easy when I was reading the rule to you, then to make it easy for you, you're always going to what?
Read it to ourselves.
Read it to yourself, exactly. And then after you read it to yourself enough, what happens in your brain?
You remember it.
You remember it, yeah. You ever walk somewhere you've never been, and so you have to follow the directions to get there? But then if you do it a lot, you leave your house to come to school or whatever, sometimes you get to the school and you're like, I don't even remember getting here, right? Because I was talking to my friend or thinking about something or whatever. Sometimes when you get somewhere, you don't even remember that you went. Yeah? Because you've done it so much. Okay? All right.
I've done it before when you're reading a book in the car.
Yeah?